Good morning, students. Today I will teach you the first chapter of your syllabus in chemistry is solution. In the series of the lecture, I have already explained you the basic parts of solution, that is how to solve the numericals based on molarity, normality, mole fraction, ppm, mass percentage, volume percentage, strength of solution, and the different formula for dilute solution M1V1 equal to M2V2 so far as N1V1 equal to N2V2, like this. Now after that, the very important topic in solution is Henry's law. Actually, this is based on effect of pressure. Dear students, anybody can explain what's the effect of pressure on the solubility of gas in a liquid? So far as Henry law is concerned, the solubility of gas in liquid is directly proportional to pressure at constant temperature. That means pressure is directly proportional to the molecular mass of the gas. More the molecular mass, more the intermolecular force, more the pressure, and more the solubility. Mathematically, Henry law is stated as mass is directly proportional to the pressure. Mass is equal to Kh into P. Now what is Kh? Kh is Henry's law constant depends upon the nature of the gas. That is why it has been written, it is the function of the gas. If I take Kh here, the mass divided by the pressure. If mass is kept to be constant, that is why more the value of Kh, greater the value of Kh, lesser the solubility, and it's vice versa. If I put to a question, out of hydrogen and helium, which is more soluble in water? Obviously your answer is hydrogen, because helium is an inert gas. That's why SQR divers make the use of the helium to make the dilution of the oxygen gas. Dear students, this is the one of the mathematical form of the Henry law. More the value of Kh, lesser the solubility, lesser the pressure. I say in the second form of the Henry law is that pressure is directly proportional to the mole fraction. Pressure is equal to Kh into chi. Chi is in short term known as mole fraction. So this is the another form of the Henry law. Dear students, application of Henry law. What the application of the Henry law? It is very much mentioned in your NCERT book, on which you follow NCERT questions. And the question is, state Henry law and mention some its important applications. One of the important applications of Henry law is that to make the solubility of CO2 in water, high pressure is applied. More the pressure, more the solubility. For example, making soft drink, beverages, cold drinks, all the phenomena which you find application in day-to-day life based on the Henry law. For example, second application is SQR divers carry the cylinder of oxygen and helium rather than the nitrogen to avoid bend. Anybody can tell me what is bend? It is a medical symptom which causes chest pain or nose bleeding. That is very fatal or painful for life. Now, last important application of Henry law is that is people working at higher altitudes are suffering from anoxia. What is anoxia? Anoxia means unable to think properly, no logical thinking comparatively the people living at the lower altitude. So due to low intake of oxygen, people working at high altitude are suffering from anoxia. So these are the very important three applications of the Henry law. First, to make the solubility of CO2 in water, high pressure is applied. Second, stewardess carry the cylinder of oxygen and helium to avoid bends. Third one, people working at high altitude are suffering from, you see, anoxia, low thinking capacity due to low intake of oxygen. Dear students, see, based on the Henry law, what are the limitations of the Henry law? Anyone tell me? Limitations of the Henry law is that the gaseous molecule should not react chemically to each other. Second, gaseous molecules should not undergo dissociation and association. And the third one, limitations of the Henry law is that gas should not be soluble to very high pressure. And after that, one important question which is put forth this year in 2020 CBSE final examination, numerical based on Henry law. Okay, I will read the numerical and write down everyone. Numerical is Henry law's constant for the molality of methane in benzene at 298 Kelvin is 4. This is the KH, Henry's law constant. KH is 4.27 into 10 की power 5 mm mercury. Calculate the solubility of methane. What we have to calculate? Solubility. So underline it, make it question. What we have to calculate? Solubility of methane, and the data provided to us is the KH, that I mean Henry's constant, and the solubility of methane in benzene at 298 Kelvin under 760 mm pressure. So what is the atmospheric pressure? Is the 760 millimeter of mercury. Anybody tell me which formula you can apply here? So apply the Henry's law. Pressure is directly proportional to the mole fraction, and pressure is equal to KH into mole fraction. And what we have to calculate? This is the solubility of, that is why, and mole fraction equal to pressure upon KH. How much the pressure here? This is the 760 mm mercury divided by 4.27 into 10 की power 5 millimeter of mercury. That is very simple numerical, actually based on this law. Therefore, this is the cancelled out. 760 into 10 की power minus 5 divided by 4.27. The way you can calculate the mole fraction. I hope everybody is able to solve this question. 17.44 is the 1.78 into 10 की power minus 5 is the right answer. So I hope I have made it very clear. It is the 1.78 into 10 की power minus 5 is the right answer. So out of three parameters, pressure given, we have to calculate mole fraction. KH is given. Therefore, out of three parameters, the third one can be calculated. I hope I have made it very clear about the